Hi everyone, welcome to the Art of the Possible series. I'm Nihalini Yogi and I'm a Principal Cloud Solution Architect at Microsoft. Today's session is part of the ISV series on network security and SD-WAN connectivity partners in vWAN. Just to recap a few useful links, and all of the links are shared below. This is the link to the Art of the Possible GitHub repo. Then we also have a link to the YouTube channel and the specific playlist on the ISV series, the security and SD-WAN partners. And this is a link to the official Azure documentation about NVAs in vWAN Hub. And if you've been following along with me, this diagram would look familiar to you. And just a quick review, this is the layer in question about partner NVAs, the tab in question, and of course, these are all reusable architectures available to download. And going back to the Azure documentation, there are a few different type of security, different type of partners. Here, a combination of security partners, SD-WAN partners, and of course, today's topic is the dual role SD-WAN and security. Fortinet provides that unique capability, and of course, our SaaS offering. So today with me, I have a few very special guests. I'm joined by Martin Twombly, who is a principal cloud architect at Fortinet. I have Cynthia Trugger, who is a networking global black belt and also my accomplice on the ISV series, and a diverse set of my peers from various orgs within Microsoft. So thank you everyone for joining. And with that, I will turn it over to you, Martin.
Thank you, Nahali. Thank you, Cynthia, and all. Nice to be here with you. Let me try to share my screen here. Let's see if it'll come up. How does that look?
Looks good. Thanks, Martin.
Good. So yes, I'm Martin Twombly. I work at Fortinet. I'm a principal cloud solutions architect here. And I'm also on I'm the, I guess, senior technical resource on our alliances team with Microsoft and Azure. And I'm also on the cloud consulting team. So I work directly with customers, developing cloud designs and integrating solutions into Azure specifically. So today I'm going to be talking about, as Nahali mentioned, FortiGates running inside virtual WAN hubs. So this is called a managed application. And it's very specifically architected to work seamlessly with Azure vWAN to provide cloud on-ramp connectivity as well as security. Let's see. If I can get my slides to change. Here we go. So a quick introduction to Fortinet in case any of you don't know who we are. Fortinet is a firewall company, firewall networking, and converged, any sort of converged security and networking. It was actually a key insight in the early days of Fortinet that networking and security should be integrated, should be converged. And so our first product was FortiGate. It came out something like 7 years before Gartner came up with the term next-gen firewall, but it was already doing that. It was already incorporating various network features, routing. It was doing traditional firewalling, layer 3, layer 4 policies, as well as deep packet inspection. And we've continued to consolidate networking and security since then. We have switch lines and wireless access points, and we have a whole fabric levels of integration with different security products, different networking products to give the full visibility as well as extend security into every part of a network, including, as we're talking about today, including into the cloud. As you can see from this slide, we are recognized as a market leader both in next-gen firewall and in SD-WAN by Gartner. We also participate in various third-party independent analyses. I think the most famous one currently is Cyber Ratings, and we score very well on those as well. So just a quick intro to who we are and why it's valuable for us to be inside Azure vWAN, what features we bring to bear. This is a little taste of our level of integration with Microsoft. As a company, we have, as it says here, over 150 different integrations into different products of ours and different products of Microsoft. Many of them are public cloud focused. That's a central part of our current strategy, but a lot of them are physical data center or branch focused as well. We have integrations with Windows Server, with Active Directory, with Azure Stack, and then of course lots of integrations, as I mentioned, with Azure. The primary one we'll be talking about today is FortiGate VM, but I'll also be using FortiManager running in Azure as well. So we'll see some of that. I'm going to skip right into the content. There's some more kind of details that we'll get into later about FortiGate specifically and relevant things with it running in Azure, but I want to talk about the core content first. So I am stealing your diagrams, Nolly, for two reasons. Number one, I really like them. I think they're amazing. And number two, I think it just helps with the conversation if we're not trying to figure out new diagrams and remapping our minds. So I'm going to go with your diagrams. So we have Virtual WAN Hub in the center here. Then we have spokes. Those would be Azure VNets. Those are at the top of this diagram. And then at the bottom are all the various levels of on-ramps. So branches with site-to-site VPN, clients with point-to-site connectivity, and then an HQ, maybe a data center with ExpressRoute, and Azure VMware Services there at the bottom. In my opinion, oops, I'm one slide ahead of myself. So what I'm going to be adding to Nahali's deck here, or Nahali's diagram, is the FortiGate VMs, and that's the little blue boxes with 3 lines they'll represent our FortiGate VMs, and we'll be talking about their SD-WAN capabilities as well as next-gen firewall, and those will be 2 separate use cases, and then we'll talk about how we can combine them. In my opinion, the real power and scope of vWAN comes into play when you go cross-region, multi-region, and when you're doing dynamic routing across region. This is where vWAN really shines. So that will be kind of the focus, but most of the conversation will be narrowed down to a local region just for simplicity. And we'll start with next-gen firewall feature set. So here I have 3 FortiGate VMs behind a load balancer, an Azure load balancer. This is probably going to appear as a fairly common architecture if you've been following along with any of the other Azure partners that are doing similar things. And so each of these FortiGates will sit here as a virtual machine inside an Azure VM scale set. They're going to be sitting behind an Azure internal load balancer. And routing intents, which is, if you're not familiar with that, it's a policy that you enable at the hub level, and it applies to anything connected to that hub. There are 2 policies that you can apply. One is local or private routing, and that will give you summary routes for the RFC 1918 network spaces. So we'll give you routes to those summaries, and the next hop would be the front end of this internal load balancer. There's another policy, which would be the internet policy, and that just gives you a default route, 0000/0. with the same load balancer IP front end as the next hop. When you apply those policies, it gets pushed to anything connected to the vWAN hub. So you apply it at an individual hub level. If you have multiple hubs, you'd have to apply to each hub its own policies, and it gets pushed to everything connected. So in this case, both spokes, the branches, the clients, HQ, and even AVS. Anything that comes from any of those networks and enters into the vWAN hub will receive the policy. And as we go through, if there are any questions, feel free to speak up.
Yeah, Martin, I have a question about the number of instances that get deployed inside the virtual WAN hub for managed deployment. Here we have 3, but I think for the previous deployment we had 2. How many instances are getting deployed actually?
Yeah, good question. So there's a scale setting that you choose when you deploy. And based on that scale size that you select, that determines both the type of instance that's deployed as well as the number. In this case, for next-gen firewall, we can go two instances up to 5 instances, and they're all active. They all sit behind the load balancer, so they're all capable of routing traffic at the same time. In the other deployment that we'll go back to, the SD-WAN deployment, right now we only support up to 2 instances, and minimum of 2, maximum of 2, but different instance sizes within that. So that's why I showed I showed 3 instances here to sort of differentiate it a little bit, but it could be 2 instances in next-gen firewall as well.
Okay, thank you.
Sure. And I have a slide later on that will talk about performances at different scale sizes, so we can get into that a little more too. So going back to how this works from a network perspective, with the routing intents policy applied, what you would see in the spoke is those RFC 1918 summaries. So if I'm trying to communicate with another spoke, I would have a summary. Let's say this is 10.0.0.0/24, and this is 10.0.1.0/24. That would fit obviously within the RFC 1918 summary. So traffic leaving this spoke going into the hub would follow that route and end up on the load balancer. The load balancer in Azure is almost kind of like a bump in the wire with this configuration. It's called the HA ports feature, and it's available in vWAN Hub as well as in regular Azure VNets. And so it forwards packets unmodified to the backend. It balances them based on the 5 tuples, but it forwards completely unmodified. So the packet doesn't have to be destined for the load balancer or anything like that. It's actually destined for something over here. The destination IP of the packet would be the VM or the endpoint in spoke 2. But because the next hop in routing is the load balancer IP, it will hit that first and then get distributed to one of the active members of the pool here. So the load balancer chooses one, sends it there. That FortiGate processes the traffic, assuming it's allowed, and routing is configured correctly on the FortiGate, then it would forward it back out. It would go over back into the local Azure fabric of the vWAN hub, which will have a peering to spoke 2, and so the traffic will be forwarded along. And then if we look at the return, would follow the exact same process. So on the return traffic, spoke 2, the fabric here has that summary route for the 10.0.0.0/8 network with the next hop of this IP of the load balancer. So it will just forward it here. That load balancer then is session aware. So it would recognize this flow is tied to an existing session. It would forward it back to the same backend member and then onto the spoke or onto spoke 1. Now, if we think about that same routing intents policy is going to be applied to the gateways as well. Then if we look at any other sort of flows, and I know this looks kind of messy, but a flow from a branch over to another branch would go through the VPN to the VPN gateway, hit the routing intents policy, go to the load balancer, then be balanced to one of the FortiGates and go to the other branch. Similarly, if we were talking about some other connection, right? So client connecting in through the P2S VPN gateway, same thing. It hits routing intents, gets forwarded to the load balancer, forwarded to a FortiGate, and then in this case, they're communicating something in the data center. So we'll go to the express route gateway and across express route to the data center. The only piece that doesn't get impacted by this is global reach. So if you have two sites connected, in this case, Azure VMware Services and the HQ site are connected to ExpressRoute with global reach enabled. So that traffic doesn't ever enter the vWAN hub. It bypasses entirely. So it won't have the routing intents applied to it. Now, if we look at this now at a bigger section and we say, okay, how can we communicate from from one region to another, maybe from a spoke to a branch in a remote region, or a branch to maybe a branch in a local region to a branch in a remote region. It follows the same process, but twice. So routing intents policy is applied to spoke 1. It gets forwarded to the load balancer. Load balancer forwards to a FortiGate. In this case, I chose the one on the end because it was easier to draw the line, but it could have been any of them. Then it gets forwarded across the Azure backbone into the second vWAN hub, where again, the local routing intents policy in that vWAN hub is applied. It goes to the load balancer. The load balancer chooses a backend member. That FortiGate processes it, and then in this case, sends it to the VPN gateway and across to branch 4. And of course, the return, same thing happens, comes in the gateway, routing intents, goes to the load balancer. It's probably getting boring now, right? Goes to the FortiGate, back across, load balancer, and then FortiGate, and back to the spoke. So routing intents forces everything to the load balancer, which then maintains symmetry for this next-gen firewall use case. And so we can do whatever deep packet inspection. We don't have to really worry on the FortiGate about routing. I mean, we're engaged in the routing, and we have to know where to send packets, whether it's out our primary interface or secondary interface. But we don't have to worry that traffic is going to come back to the wrong FortiGate. Any questions on that? It's probably fairly common amongst other
So
partners.
Martin, real quick, the load balancer that you have shown here is the internal load balancer. Do we also have something that allows you incoming services, and how does that work?
Yeah, good question, Holly. Thank you. So right now we do have something, but it's in preview. So for the last, I guess it's been about 3 years, there hasn't been the capability of publishing service, of having what is usually referred to as Internet Edge Inbound. But that is now available in preview. And I do have a slide later that'll get into that. So for these deployments and everything we're talking about so far, it's just the internal load balancer. In each of these now, you can also, I have to be careful how I phrase this. At deployment time, you can choose to also add an external load balancer. That's only available at deployment. So if you want that and you already have a deployment, you'd actually have to redeploy to get that. And I'll talk about that a little bit more. But for all these diagrams, you're correct. It is the internal load balancer.
Thanks, Martin.
Sure. So now let's talk about SD-WAN. We'll shift gears a little bit. So the SD-WAN use case typically doesn't use routing intents. Rather, it uses BGP peering. So there's a BGP router in the vWAN hub, similar to Azure Route Server, but not identical. And that allows us to advertise routes from the FortiGates into the Azure Fabric. And that gets then shared across spokes and even across ExpressRoute or other connectivity. In this case, for the diagram, I've removed the site-to-site VPN gateway. You could use it in addition. There's nothing to preclude that. So you could have some SD-WAN, and you could use the site-to-site tunnels. You could also do sort of double tunnel where you go through the site-to-site tunnel and then terminate a tunnel on the FortiGates for SD-WAN. It's not very common, but it is possible. We've also seen some tunnels go through ExpressRoute. So there are lots of ways to configure this. This is the most common way, where you wouldn't necessarily use the VPN service from the vWAN hub, but you would terminate tunnels directly on the FortiGates with the public IPs. So I didn't show the public IPs previously, but there are public IPs associated with the FortiGates. These are there really exclusively for tunnel termination. They can't be used for internet edge inbound, and there are only very few ports that are open on them, mostly for either troubleshooting or for tunnel termination. So UDP 500 and 4500 are open to those, but not much else. Yeah. Was there a question?
Yeah, sorry, Martin. I see that for a given SD-WAN branch, there is a tunnel towards each instance. So is that how the Fortinet SD-WAN solution works? We have a tunnel towards the instances of a same cluster.
Yes. Yeah, good question. So we do recommend, and it is possible to tweak this, but the default deployment and the recommendation is that both of these FortiGates would be active, and so you'd have a tunnel to each of them, and then we figure out where the packets need to go. For SD-WAN only, it's not a big deal because we don't really need symmetry. It's primarily routing. We would have some layer 3, layer 4 firewall policies there as well, but we can synchronize sessions across the FortiGates and allow asymmetric routing in that way. So yeah, there would be a tunnel to each FortiGate from each branch, at least one tunnel. In the case here of branch 1, I show 2 different tunnels. And that's just the idea there is if you had 2 ISPs, you'd have a tunnel from one ISP to the first FortiGate, and from that same ISP to the second FortiGate, and then from the second ISP, you'd have a tunnel to each FortiGate as well. And this way you can do full SD-WAN. So you can load balance, you can prioritize one or the other, you can send some traffic one way and some another way, all the fun stuff you can do with SD-WAN. And it's not limited to 2 tunnels, you could do 3 or 4. And it's not necessarily limited to tunnels. There are ways you could do it by routing traffic in another direction as well.
Martin,
yeah.
Nahali, I have a question. So I noticed you had 3 instances when we had the firewall, the NGFW. Here you're showing 2 instances. Is there a difference in the scaling?
Yes, there is. Yeah, exactly. So with the NGFW solution, we can do up to 5 instances. With SD-WAN right now, only support 2 instances. We're looking into increasing that, but as we talk through this, you'll see that there may be there may be some diminishing returns with adding additional instances. So right now it's limited to 2 for the SD-WAN solution. Yep.
Thanks.
And Martin, I have one more question. So for a given branch and for a given underlay, we have a tunnel to each instance. And would the traffic be load balanced across both tunnels, or would only one tunnel be used?
Yeah, it depends on the configuration at the branch. So,
Okay.
so the branches has SD-WAN, and it can choose which. So it can choose, or you have policies. So you have SD-WAN policies, and you could have an SD-WAN policy that just does load balancing across both, or you could have an SD-WAN policy that prioritizes one and then uses the other one as a fallback, or you could have policy that sends voice traffic one way and
Okay.
other traffic a different way. And you can do a combination. So if you had, let's say you had 3 tunnels, you could load balance over the first 2 and use the third as a backup, or other things. Yeah.
Thank you. But I was talking, let's take the example of branch 2, where we only have one internet
Yes,
connection.
yes.
Yeah.
Yeah, in that case, it's most likely load balanced. And certainly from traffic originated in Azure would be load balanced between the 2 tunnels. If it's originating from the branch, it could still be configured to prefer one over the other, but there's not really, in my opinion, a great reason to do that, unless it's just like for troubleshooting purposes and you want to see the traffic always go one way. But yeah, typically it would be load balanced. Yeah. Sorry about that.
Okay, no, clear. Thank you. Thank you, Martin.
So let's take a look a little bit at some flows here with the SD-WAN only solution. So again, in this solution, we're not using routing intents. We're just using BGP routing from the Azure side. From the branch side, we're using SD-WAN policies. So if I send traffic from branch 1, the FortiGate here at branch 1 would determine which tunnel to use, again, based on its policies, and it would send traffic through the chosen tunnel to the FortiGate, and then the FortiGate processes it, drops it onto the vWAN fabric, and then there's a route to spoke 1 because of the VNet peering here. So it just follows and goes through. If we're going branch to express route, it's similar, except we would use the gateway instead of just dropping on the fabric. There's also, I didn't draw it, but you could do branch to branch. And in that case, it would just go through the local, whichever FortiGate it landed on, and then go back to the other branch over that local tunnel. So it wouldn't even exit the FortiGate into the Azure fabric in that case. So if you think about this, if these are the session initiation, then the return traffic in this case would follow BGP routing. So from spoke 1, I would actually have 2 routes to both of these branches, one through the first FortiGate and one through the second FortiGate, because there's nothing pointing traffic at this point at the load balancer. So I would just have equal cost multipath from the spoke perspective, and the fabric would select one of the routes and forward it. So I'll show you here kind of the worst case scenario that both sessions, the return flow went to the other FortiGate based on ECMP. And in this case, there's really no problem. We have a protocol called FGSP FortiGate it somehow stands for FortiGate Session Life Support Protocol. I'm not sure how the letters line up there, but this allows us to synchronize sessions between the two FortiGates over, even though we don't have layer 2 connectivity. So it's a layer 3 session synchronization protocol. So with this session synchronized and with the fact that we're not doing any next-gen firewall, this means we can just process the traffic asymmetrically. And each FortiGate recognizes these sessions as existing, even though they were initiated on the other FortiGate, and processes it according to its own settings. So, you know, in the case of traffic going back to branch 1, we would actually have 2 tunnels from each FortiGate. So again, it would just choose based on the fact that it has 2 equal cost paths, and it would choose one of them.
Quick question. Sorry,
yeah.
Martin. Not directly related to the flows, but how does the SD-WAN deployment in a hub scale in terms of bandwidth? Bandwidth available at the like SD-WAN OS level?
So, sorry, can you repeat the last?
Yeah, sorry. I'm just trying to understand which bandwidth the SD-WAN deployment inside the virtual hub can manage. The throughput available.
Yeah, so okay, thank you. Yeah, so the throughput is contingent. In this case, it's only 2 instances, but it would be contingent on the instance size. So depending on how many CPUs we have to work with, we can scale vertically in that regard to support more or less bandwidth. So we distribute the load across multiple cores for multiple tunnels. And I don't remember exact numbers, but I do have a slide later that will talk about that in terms of IPsec, and then also in terms of firewall inspection.
Okay.
So it does scale. So it does in this case, and it's kind of an interesting discussion from an HA perspective, but in this case, it does scale to 2x, right? So whatever, if one instance type could do, 3,000 megabits, and we have now 2 of them, we should be able to do 6,000 megabits cumulative. Now that assumes, we have pretty efficient load balancing, and we don't have, huge maybe backups or something all going to one FortiGate and then little minimal traffic going to the other FortiGate. There are potential issues there where you may not be able to fully distribute the load, but for the most part, the load balancer in Azure works very well. It works linearly, so it doesn't impact the performance in any way. So it really is good in that respect.
Thank you.
Yeah. So now these are FortiGates, and the whole point, or as I mentioned at the beginning, one of the key sort of priorities of Fortinet is to converge networking and security. So we have a product here that's doing SD-WAN, but it's fully capable of doing more, of doing certainly next-gen firewall and unified threat management type work. So what if we turn that on? What would happen? So if this is our source, these are our session initiations, and now we turn on next-gen firewall, what do we do in this case? And the sort of key difference here is that with next-gen firewall, we want to see both sides of the traffic and inspect that So if we're doing IPS or maybe application control or some sort of deep packet inspection, certainly SSL decryption, we need to see both directions of the traffic on the same instance to be able to adequately evaluate and provide the best security. So what we do now, if you enable the next-gen firewall, is we still have that session synchronization protocol, which so both FortiGates will know about both sessions, but they also know where the session originated. So when traffic returns asymmetrically, as in these cases, the receiving FortiGate will recognize this is an existing session, but it originated on my peer. So it encapsulates the traffic. So it's configured to know that it's in an environment that doesn't allow layer 2 connectivity. So it encapsulates it and forwards it to the peer. And then the peer, which was the original FortiGate that received the session initiation, will process the return traffic symmetrically. So this is the sort of magic that makes it possible for us to do SD-WAN and next-gen firewall on the same product and still do multiple active scenarios. So questions on that? It's kind of unique, so I don't want to skim over it. Okay.
Yeah, maybe just, I think I know the answer, but when we have SD-WAN plus NGFW, again, it's 2 instances, right?
It is.
Yeah. Yeah, okay. Thank you.
Yeah, and this is really the reason. So as I mentioned, if we're doing SD-WAN only, in theory, we could go bigger because we can forward things asymmetrically. There's still some overhead of synchronizing the sessions that you wouldn't have in a next-gen firewall only deployment, but but once we add next-gen firewall with SD-WAN, which is the typical use case, now we're talking about synchronizing sessions, but we're also talking about rerouting some of the sessions, perhaps up to 50% of the sessions get rerouted. So there's overhead involved in that. And if you're doing synchronization 3 ways or 4 ways or 5 ways in a meshed environment, and then you're doing rerouting all over the place, we're not sure that there's a benefit of scaling really beyond. And my hunch, based on working with it, is that there's some benefit to 3. At 4, it's probably kind of the same as 3, and then at 5, it may be you may be going backwards because you're just doing so much overhead that you're using up the instances with the overhead. So we're evaluating. That's on my plate to test and try to figure out where it makes sense and if we can scale larger. And one of the key reasons is to provide high availability. So maybe 2 instances are adequate for the bandwidth requirements, but what if one of those instances goes down? So ideally, we'd like to get to at least 3, so that we have 2 with HA. But yeah, working on that. So one other thing to mention here is I talked about with SD-WAN only, we wouldn't be using routing intents. And you could certainly do SD-WAN and enable next-gen firewall, and basically with the expectation that you would only be inspecting traffic if it's using the SD-WAN. But you could also here enable routing intents, and it would work the same way, because without routing intents, we have ECMP. With routing intents, then we have the load balancer. So in both cases, we have this potential for asymmetry, and we have both FortiGates in the path. The advantage of routing intents, of course, is then we could also inspect traffic going between spokes or going between other networks that aren't doing SD-WAN. So, so it could be turned on or not, just depending on the actual use case. So let's look at the same thing going cross region. And I just realized I don't have the right label here. So this should, both sides should be doing SD-WAN and next-gen firewall. But traffic would come in, if we have routing intents enabled, come in through the load balancer, go to a FortiGate, get forwarded cross region, hit the load balancer there. And this is where routing intents is required, because otherwise we may not hit both load balancers, and we could run into kinds of problems. So when you start going cross regions, routing intents is very, very useful. And especially if you want to inspect traffic between spokes. But so here I would hit the load balancer, go to the FortiGate. FortiGate would select a tunnel, forward it to branch 4. Now in this case, the return path, interestingly, is very symmetrical, because branch 4 is going to recognize this came in over certain tunnel, forward it back over the same tunnel to the same FortiGate, goes back to the first region where the traffic already went through the load balancer the first time, goes back to the same FortiGate, and then to the spoke. So in that case, we had a perfectly symmetric discussion. But it's interesting, because if we turn it around now and we say, okay, what if this is, instead of this is the return path, let's say this is the initiation. So I'm coming from branch 4 talking to spoke 1. So when spoke 1 replies, then the traffic coming through the first time did hit the load balancer, so it'll forward symmetrically there. But when I get to the second region, in this case, the traffic didn't come through the load balancer. It came through a tunnel and then the FortiGate, and the FortiGate drops off on the fabric. So the load balancer is only in the conversation in one direction if we're using tunnels. So then what would happen here is I may potentially get routed to or get load balanced to the wrong FortiGate. And the same thing that we talked about earlier, we would reroute that back to the originating FortiGate and then forward out the tunnel that it originated on.
A quick question, Martin, over there. So at that point, the left, so the inspection happens on the left FortiGate and only one of the right FortiGates, right? On the second region. In other words, routing happens first and then the inspection.
Right. Well, yeah, so routing from the load balancer perspective, but then the FortiGate, essentially when it receives it recognizes this basically on a packet basis. And of course there's fast switching. So once it recognizes the initial return packet, then it would identify that as a flow, and it would just automatically forward everything that comes in on that same flow the same way. But so here, where this FortiGate recognizes this isn't my session, this is an active session, but it's not mine, it forwards the packet back to the original FortiGate. So then the original FortiGate would determine routing as well as security.
I see. Yeah, I just want to make sure if there is any kind of performance hit in those flows.
Yeah, that's what I'm trying to determine as well. There is a performance hit, because we're we're now using both FortiGates for this
Yes.
flow, right? Yeah.
Yeah.
But that's to what extent and how far can we push that is kind of an open question for us still.
Mm.
Um, let's see, trying to get my bearing here. Okay. So this is something I wanted to talk about. That's an interesting sort of what if scenario. And we've seen it a couple of times, which is why we know about it. But it's a fun thought experiment, and it's useful to know how to work around it. So, what happens if all the tunnels from one branch to one of the FortiGates are offline, but the other tunnels, or at least one tunnel, is still online to the other FortiGate? So the design, as we talked about, and I think Cynthia asked the question, is sh should the tunnels go to both FortiGates? That is the expectation. That's the design. But what if that isn't configured correctly, or what if one of those tunnels fails for some reason? Is it possible to recover in that situation, or do we just assume that nothing's going to work? So, um, so I had a customer have this scenario. So if you see the difference between these two slides is those two tunnels between branch one and the second FortiGate are gone. So let's say they just failed. Now, if traffic's originating from the branch, again, it's flow specific, right? If it's originating from the branch, goes through the FortiGate and to the spoke, no problem, because the return traffic would come, let's say, to the load balancer, or would come based on ECMP. But if it comes based on routing intents to the load balancer, that's really the problem that we're addressing here. So if it comes to the load balancer and gets sent to the wrong FortiGate, again, it's not a problem because this is just going to forward it back to the originating FortiGate. But if traffic's initiated somewhere else, whether it's AVS or whether it's a spoke, and it comes to the load balancer doesn't, it's not network aware. It just knows, are these backends are these backends responding to probes or not? And if they are, then it will forward traffic. So traffic coming from spoke one to the load balancer could come to this FortiGate for branch one, but this FortiGate has no tunnel, no way to get to branch one. So I'll tell you, I came up with this very cool, I was very impressed with myself, fix for this. I set up a VXLAN tunnel between the two FortiGates. I configured dynamic routing between them as a backup. So if there's no other routes around, then it would use this tunnel. I wrote up documentation, and it confused customers to no end. They would frequently configure it backwards and create loops. And so I had this member of my team who said, Martin, you have a route. Why don't you just use the route you have? I'm like, what are you talking about? I have a route. I don't have any tunnels. And he said, well, if this FortiGate has tunnels to branch one, that network's getting advertised to this FortiGate. And this FortiGate is advertising the network to the Azure vWAN Hub BGP router. And that router is advertising the network to this FortiGate. So there's a much simpler solution that's far less problematic, and that is simply to use that route that we're getting from vWAN Hub. So if I get traffic from spoke one to FortiGate 2, and it doesn't have a route to branch one, it can simply allow the traffic back out onto the Azure Fabric, and Azure Fabric will reroute it to the FortiGate that does have the route. So it's very simple, basically just requires a second policy that would be lower priority. So it wouldn't match in regular case, but it'd be a second firewall policy that allows In this case, it would be interface to interface, so port 2 to port 2, kind of like router on a stick. It's similar to what we would do if we were allowing traffic from spoke 1 to spoke 2. And so as long as we configure that on the FortiGates as a secondary firewall policy for any spoke to branch traffic or any other vWAN hub connected networks as well, then everything works fine. So questions on that? It's kind of weird, but okay. So this is now, Holly, I think, did you ask about this earlier? The internet ingress.
Yes. Yeah.
So this is what is typically in cloud network design called the load balancer sandwich. And this we use frequently outside of Azure vWAN, but it wasn't available until recently. And now it's available in preview, where you can have an internal load balancer and you can have the external load balancer. This was a feature that's been asked for by customers ever since we went into preview with the initial design, and I'm sure other partners had the same questions. So the trick here is the IPs that we use to terminate the tunnels, they're still here. I probably should have included them, but those IPs are part of the managed application, so they're controlled and they're in an Azure subscription rather than in the customer subscription. But in order to make this work, they wanted to actually have the public IPs to be customer resources that customers could configure as static. That's one big problem with the IPs that are managed by Azure. They're not guaranteed, so they could, if you redeploy, for example, you can't reuse those IPs. You have to create new ones. So for those reasons, for this design, it was desired that the customer manage their own public IPs. So these public IP resources exist within the customer subscription. And this connection to the external load balancer is very unique. It's a cross-tenant connection to the public IP between the load balancer and the public IP. So that's the new bit that was developed in order to make this work, and it's very slick, and it allows persistence of those public IPs. So if a customer needed to move them around, maybe they're publishing a resource. Maybe they already have a resource that's published and they want it to go now be published through a deployment inside Azure vWAN Hub. They could take that existing public IP and reassign it to the external load balancer here and continue using it. They wouldn't have to get a new IP.
So Martin,
yeah.
Quick question here. So these public IPs are in addition to the public IPs that were used for tunnel termination. In other words, when we set up those SD-WAN tunnels, is that they were using public IPs.
Correct. Yeah. Yeah, and they are different. Those public IPs are inside the Azure subscription, and they're still here. Sorry, I didn't include them in this diagram, but they're still there. So with this design, you could still have your tunnels, your SD-WAN tunnels, directly to the FortiGates, and they would use those public IPs that are directly associated to the FortiGate VNIC. And you would use these public IPs for, let's say you have a web server that you want to publish, or any sort of ingress. Yep.
So when the firewall, you mentioned, sometimes the IPs get reassigned, so we don't have that issue with the VPN peer IPs, in other words. In other words, the ones that are on the FortiGate used for VPN termination.
So those do have that issue, and the issue would occur if you were to redeploy the. Let's say for example you wanted internet ingress,
Mm-hmm.
and you have a deployment that's been there already for a year, and you say, okay, how do we add internet ingress? Well, you can't. There's no way, at least currently, to add the external load balancer to an existing deployment. So what you would have to do, the config would be already on the orchestrator, which we call FortiManager. So you'd have the config of the FortiGates backed up, stored, but you would have to redeploy. So you would have to, and most likely what you would do is you would deploy a second group, a second set of FortiGates in the same vWAN hub, and then you would configure those, and then you would delete the first set. But when you do that, you will lose those public IPs and you will have new public IPs on the new deployment. There's no way to move the existing public IPs. So there would be some configuration changes on the branches.
Mm-hmm.
They would have to be updated to know about the new public IPs. So that is still an ongoing, that's just the way it works right now in vWAN Hub, and there's no capability so far. That is something that I think they'd like to change, and they're trying to figure out, okay, could we do the same thing, cross-tenant connectivity of these public IPs to the actual VNets? That's not supported yet, but it's maybe a future. So definitely an NFR for the Azure vWAN team. But these new public IPs that would be associated with the load balancer, those are standard public IPs, and they're managed by the customer, so they can be moved from existing deployments to vWAN. They could be moved from a vWAN deployment to another vWAN deployment. They could be moved from a vWAN deployment back to, a platform, or back to a VM or some other deployment of NVA somewhere else. So they're completely managed by the customer, which is a better scenario. Does that make sense?
Thanks, Marty. Yeah, yep. Thanks.
Okay.
Yeah.
Yeah, Martin, just a quick question about this scenario. So today it's in public preview only, right?
Yes. Yep. Yeah, it's only in public preview currently. So from Fortinet's perspective, we have completed the development and testing, so we consider it GA from our side. From the vWAN side, it's still public preview, and they're working on GA. I don't yet have a date for that, though.
Thank you.
Okay, so let's move on to the performance. And performance is always an interesting discussion with firewall, because there's 23 different numbers, and there could be 500 if you tested different things. So so at Fortinet, we try to be very conservative. So everything here, all these numbers are in our data sheet, which I think Nahali will send out or post the links to this. But they're very conservative. They're tested in Azure specifically. So we have different data sheets for different clouds, and different data sheets for private clouds, and different data sheets for obviously all of our hardware. But in this case, we've tested IPsec throughput, we've tested next-gen firewall, and we've tested just general firewall throughput. So when you deploy, and when we get to the demo, we'll go through a deployment. There's a very simple number that says 10 gigabits, or I think it's 2 gigabits, but you select the scale size, and it tells you this is what the performance is. And just because of the context, it has to be simplified, but the reality is obviously much more complex. So depending on, are you doing SD-WAN with IPsec? Are you doing IPsec with next-gen firewall? Are you doing so? There's a million permutations and ways of measuring performance. So this, I think, is the most relevant information, and probably certainly if you go with the next-gen firewall number, then you'll have the most conservative. and you'll know, okay, at least I can get this much performance. Now, of course, if you do next-gen firewall with SSL decrypt and all super tiny packets, maybe you won't even get that performance. But for general internet, general enterprise mix of traffic, this is the performance you can expect. Now, I did the per instance numbers, so you'll see here, like, it doesn't change once we get to 20 scale size, then we're at the 16 core instance. So all the per instance numbers are the same. But of course, with next-gen firewall, because we're just the load balancer, which is part of the fabric, right, is just steering the traffic for us, and each FortiGate is processing its own unique traffic. So these really do scale linearly. So if you say, okay, one instance can do 6.8 gigs, then, you know, multiply that by however many instances you have, and that's the performance you can expect. Questions on that?
No, it's clear. Thank you.
Okay.
Maybe just a comment about, I think you mentioned that on the portal or when doing the deployment and selecting scale units, you get a generic throughput value.
Yes.
And I think that's the value actually of the bandwidth available at the throughput available at the VM level. So for the underlying instances, and of course, as you said, you know, depending on the features you'd apply and encapsulation, etc., we would then have that well lowered because of all these features added on top of that. But yeah, just wanted to say that the value displayed on the portal is matching the underlying VM capacity.
Okay. Yeah, that's helpful. That's helpful. Okay, so one more detail slide. The way licensing works for FortiGate, we do have a pay-go option with Azure Marketplace, but it's a separate deployment. So if you deploy with pay-go and then you want to switch license types, you have to redeploy to get the BYOL image, because it's actually a completely different deployment model. And there's also you know, different things going on in the back end. So even if you did replace the license, even if it was possible, you would still be getting charged for the pay-go. So so they're not interchangeable is kind of the point of this slide. You have to select your license at deployment time, and if you want to change, you would redeploy. Now for bring your own license, so if you're purchasing licenses through one of our partners that's not Microsoft, we have different options there. The traditional sort of BYOL, you would purchase a license for an NVA for a FortiGate in this case, and then maybe you purchase a subscription on top of that, or maybe you just purchase a pure subscription model. That's the individual, but you would purchase it for each deployment. So if you're deploying 2 FortiGates in Azure vWAN, you would purchase 2 licenses and 2 subscriptions. We have a new model that's similar to pay-go, but it works across all of our products, whether in any cloud or in data center. You could use this same license model, and it gets charged per day. Essentially, you would buy a number of points up front, and then you have a portal to manage those points, and you issue tokens for each product. And then that token essentially gets called once a day if that product is up and being used, and then you get deprecated for those points. So it sounds complicated, but the whole goal of that is to give you a model where you can consume based on usage rather than having to pay for a license continuously. Questions about licensing? Right. So now we can talk about the fun stuff, and that is a demo environment. And I've simplified things as much as possible. Not that everything else isn't supported, but just these are the relevant things that we'll be looking at. And I've made it a little bit more complex. So rather than rather than doing only connectivity to a local region, I'm doing sort of primary, secondary region connectivity. So I have, in the case of the West Central branch here, I have tunnels to the West Central FortiGates. And then I also have tunnels to the East US FortiGates. And the concept here is I would, from an SD-WAN perspective, I would always use one of these tunnels if they're available. And again, I can have many tunnels. So if I had two ISPs in this West Central branch, I could have 4 tunnels, and I would group those together, and I would always use one of those if it's available. Then if it's not available, if the entire region goes away or something happens to those FortiGates, for example, then I would fail over. So I'll have a secondary rule, SD-WAN rule, that fails over and sends traffic to the remote region. And this gives a lot of flexibility because then I can, for example, we talked about potential upgrades that would require some downtime within a region. I could do that and I could still route through the remote region and at least get to resources in the remote region during that time. And so then vice versa, right? On the East US branch, I've flipped it. So it's communicating primarily with its local hub, and then secondary rules allow it to communicate with the remote hub. Within Azure, this is managed by routing intents at the spoke level. And within the hub level, it's managed through BGP. So BGP would determine, let's say I'm coming from spoke 1, but I'm communicating with West Central branch. I actually want to use the Azure backbone to do that communication. So based on BGP configuration, I would go, or first based on routing intents, I would go to the load balancer and I would hit this FortiGate, or one of the FortiGates, right? Based on the load balancer choice. That FortiGate will have a tunnel, or I'm sorry, this tunnel direct, but based on BGP configuration, it would be less preferred than the route that's coming over the Azure vWAN backbone through these FortiGates. So I would instead send the traffic back onto the Azure Fabric across. Again, I would hit routing intents policy, get load balanced to one of these FortiGates, and then they would have a direct path that would be preferred. So that's kind of how this whole thing works. Questions about that? All right.
So quick question, Martin. This is the lab that we would be using for the demo as well.
Yep, exactly.
And your West Central branch and East Central branch, I assume, are simulated branches within Azure, or
they are in this case, yeah. But the tunnels are public, so I'm using public IPs to communicate.
Sure.
Yeah. Yeah. And they're just single VMs in Azure native VNets.
Okay, got it.
Yep. All right, let me switch over to here. Oh, I did want to talk. So I mentioned at the beginning that I'm on the consulting team. So I'm working on the Azure Alliances stuff, but then I also work directly with customers. And we do have in Azure Marketplace this consulting service offering. So I think I sent you a link to that, Nahali. You could include that. That'd be great. But we do offer help with these kind of designs and implementations of customers like. So let's see. So I want to show you this. This is our orchestrator. This is called FortiManager, and we have different options for this. It could be a physical appliance. It could be, in this case, I'm using a virtual appliance running in Azure. But again, I'm using public connectivity to be a little more real world, I guess. And then it's also offered as a cloud service from Fortinet. So we have it where customers could just connect to it, kind of like you would think of Meraki or some of these other custom companies that do all their management through clouds. We have a similar service that customers can use if they don't want to host their own appliance. So if I go here to devices and groups, I have, because it's public, I have somebody trying to do something. Always, right? As soon as you make something public. So I have 6 FortiGates, and they're grouped in groups here. So let me show you the groups. So I have East US branches, and of course the concept here with SD-WAN is that you could trivially deploy multiple. Once you have sort of your templates worked out, you could trivially deploy multiple branches. So if I wanted to add another branch, I would join it to FortiManager, the FortiGate, and then I would put it in this group and basically click install, and it would install everything and be part of the deployment. Then I have these hub. Can I make this bigger? I can't. So I'll show you this name here. This is actually the managed application. This is what it names the instances. So they show up here. And based on the name, FortiManager automatically recognizes, oh, this is Azure vWAN that deployed this. And so it groups it into a group specifically for Azure vWAN. And there's some custom things that you can do because of that. So one thing that we'll get into in a little bit is you can manage the Azure vWAN load balancer. So this is Azure vWAN software load balancer, and we can configure rules and things here. Another thing, let's see, does it show? I think I have to select both of them. Yeah, so FGSP configuration, you can push that directly from FortiManager, and that's a Azure vWAN specific feature as well. So it knows, okay, this is an Azure vWAN group. This is you've selected both FortiGates in the group. You can push the FGSP configuration. And again, FGSP is that protocol that allows that session synchronization and rerouting of it's called UTM rerouting. So it's the next-gen firewall feature set that gets rerouted.
So Martin, real quick on this deployment, I see that you already have those 2 FortiGates deployed. So the first thing that happens is, do you deploy it first on the vWAN side and that configuration gets pushed here, or do we pull it from the FortiManager?
Yeah, that's a good question. Let me go back there. Let's see. Let's do a new tab here. So let me start in vWAN, and we can kind of go through that deployment. So I have a fairly simple subscription here, and everything I've deployed so far is in this one resource group, which you'll see a ton of stuff. So we can kind of just ignore it for now. I'm going to find my vWAN and my hubs. So I have 2 hubs here. I'll just select the top one. And if I want to deploy it's already tuned down for me. But if I want to deploy an NVA in the hub, I can come here to the network virtual appliance. And here's the one you see that I already have. This is one of the ones we were looking at. But I can click Add Virtual Network Appliance. And this is actually links back to Marketplace. So you could do this a different, in Azure, there's always 7 ways, which is good to do things. But this will link me back to the deployment of Marketplace. The nice thing about it is it will link me, it will automatically recognize that I'm trying to deploy to this hub. So it sort of pre-populates some things in the Marketplace template. We do have three options here. The first 2 go to the same place. And the third one actually links off to documentation. We're working with the vWAN team to reduce this to just one option, but for now, either the first 2 will work. The third one just sends you out sends you out to the documentation. So I'll select one, click create, and you can see here it says I'm going to take you somewhere else. So I leave the page. And now this is the Marketplace offering. Was there a question?
Yeah, actually, I had a question. What about if we just want to do a Fortinet SD-WAN deployment? Because I saw Fortinet NGFW, Fortinet NGFW plus SD-WAN, but not Fortinet SD-WAN only.
Yeah, good question. So in that case, you would still do the SD-WAN plus NGFW deployment. It would be the same
Okay.
architecture, but then the way you configure it would be the SD-WAN only piece. Yeah. Yeah,
Okay.
good question. Yeah, and we've gone around and around of should we offer more and options and where should we offer options and how do we make that? It's all these things are so hard to communicate in drop downs. But it is pretty well documented, and so I can show you the documentation as well. So if I click create here, so you're gonna create something in Marketplace. Are you sure? So I click create, and here I would select my resource group and my region. So in this case, I think it should have done West Central, but we can do East US. So you want the region to be the same as where your hub is. You configure some parameters here, give the FortiGate name prefix. So this is what this shows up in various places, but it's always appended. So you'll see this, and it only gives you a few characters here. I think it's 9 characters you can use, or 12, but then that gets appended. So that long name that we saw earlier, that this would be part of that name, but obviously not the whole thing. And here's where you would select again. So here, like I said, that link that we clicked on in Marketplace actually goes back, both of them, to the same place. So here's actually where you choose your deployment model. So SD-WAN only would be this first option. SD-WAN plus next-gen firewall also, obviously. And if you want next-gen firewall only, which really the key difference between them is if you do SD-WAN, you can only do 2 instances. If you do next-gen firewall, you can scale to 5 instances. You could still do only 2, but you have the option of growing larger.
Okay.
So I'll click next. And then I select my vWAN hub here. And then here's the scale options that I have. And these are, yeah, these numbers are definitely slimmed down from from the general marketplace. If the general marketplace has the full vWAN capacity, I think it would be bigger than 1 gigs, even on a 2-scale unit. But these numbers, if you kind of cross-reference them with that, with the performance or with the data sheet, which I think I have. Do I have it up here? No. Oh, that's my FortiGate. Well, it'll be a link that you guys can have. It'll either be available in the notes or Nahali can send it to you. But if you look at these numbers, they're actually pretty legitimate based on the numbers that the FortiGate can do. Now here, this is an interesting piece, and this is another kind of new feature request that we're trying to get through. This is the only place you can set this, and you can't change it after the fact currently. At least in the portal. There may be an AZ CLI or a PowerShell that you could change it, but there's at least no way to change it in the portal. So if you get this wrong, then you have to go back and change it. And this is the BGP autonomous system that you would use on the FortiGate itself. So the Azure ASN is always, I think it's 65515. But this is your one shot to choose this right. And I actually had to redeploy because I did some redesigns. So I had to redeploy once because I needed a different ASN. So here's where I would put in my orchestrator information. So that's the FortiManager we were in earlier. So I could put this in, and I'm using public. Customers wouldn't necessarily have to do public. They could connect to it privately, or like I said, they could use the cloud. Where did my? Oh, I can't remember where I was. I think here. Yeah. But you would put in if you have local connectivity. In other words, if it's paired with the vWAN hub and you're running it in Azure, you could just use that local Azure IP address. If it's a cross express route running an appliance, you could use that local address. You have some options there. And if I go to the dashboard, I can grab the serial number here. So this just validates that I am connecting to the FortiManager I think I'm connecting to, so that I don't inadvertently end up connecting to some malicious thing somewhere.
And is there an approval that is required on the FortiManager? So let's say we trigger this with the serial number and public IP. On the other end, on the FortiManager side, does it show up as pending, or how does it kind of integrate?
It shows up as unauthorized.
Okay.
Yeah, so I can authorize this, but I don't know what it is.
Okay, got you.
Yeah. So it would show up here in this list, but it would be very recognizable because it would have this kind of naming scheme, right? So here's that prefix that I put in. So it will show up here. It'll have 2 devices, and it'll show up with that. And oftentimes, if you're doing a large deployment, or if you're just adding multiple vWAN hubs, you may end up with a bunch of them showing up at once. But again, the names should be pretty recognizable. So, and here's the preview feature that we talked about. So Internet Edge Inbound, that's the checkbox. And then once you check that box, then you get an option to either create a new public IP or select an existing one. If you have an unused standard public IP available in your subscription, you could select that here, or you could create a new one. And you can also set up the prefix, DNS prefix. Most customers don't use the Azure DNS prefix, but if you are using it, you can set it up here. The one thing that, and this is, I think, going away soon because the basic SKU IP, I think, is going away, but you do have to click create new and change it to standard. If you don't do that, so if I don't do that and still have it at basic, when I click next, it's going to say go back and select standard. But this is the default, and there's no way to change the default. We've tried and tried. So you have to come in here and say, no, make it standard. And then when I click next, it will validate, oh, your public IP is good. And then I can go on to create. So that's the start. I think that was a long answer to your question, but that's where you start. And then once that is deployed, it would show up over here. And let me go ahead. It'll take a while, but let me go ahead and create this one. We're going to demo. And so somewhere along the way while we're doing this demo, it'll show up. You know what? I want to change it. Basics. So right now I have it set at BYOL. If I do pay go, I won't have to worry about getting a license right now. So you really have to agree when you do pay go.
If I update the scale unit of a deployment, that will recreate a new deployment, or do I need to first delete the deployment and recreate a new one?
No, you can update, especially, well, at any time, you can change the scale unit. I don't think it's exposed in the portal still. So you have to do it through CLI, either PowerShell or AZ. But if you update the scale unit, it will make the changes without being destructive. So if you're, for instance, if you do an SD-WAN deployment, and in this case, I think I did 10 scale units, let's say I want to go to 20, it would just resize the VMs and it would keep everything else in place, my configuration, my network interfaces, and importantly, my public IPs. So then I would essentially just get more throughput. It would require a reboot, of course. So there'd be a little bit of downtime.
Yeah.
Now, the other piece that doesn't get, if you've chosen PayGo, then your license will be automatically updated and you'll just get charged more going forward. But if you chose BYOL, you'll still have the old license, whatever that was. So you would have to, most likely you would have to get a new license and then, or get a new token if you're doing the FortiFlex licensing, and update your license to get the new performance. Now it'll continue to work. It'll just, you'll have now 16 CPUs, and if you were on the 4 CPU instance type before, and that you have a 4 CPU license, then you will only be able to use 4 of the cores. So if you're doing an NGFW deployment, and let's say you have 2 instances now and you go to a scale unit that's 3 or 4 or 5 instances, your new instances will come up. Your old ones will still be there. They'll be configured as they were, but your new ones will be fresh, blank instances. So you'll have to adopt them in FortiManager and configure them. And in the meantime, you may be dropping packets. So we'll talk about some mitigation you can do around that. And it'll be similar to kind of the upgrade process. I guess we could talk about that now. Let me finish going through here so you kind of have a feel of where we are in this giant tool. These management tools are so impressive in what they can do, but they're very overwhelming. So we saw at the top, I have a list of all my devices. So this shows everything that I'm managing that I've authorized. So I essentially have two lists, right? Managed and unauthorized. And then I have my groups, and these are just to help keep things organized. And these are repeats of what was above. So I have my branches, east branches, then I have my east hubs, I have west branches, and then I have my west hubs. And that's all under devices and groups. I have completely separate sections for different sorts of things. Most of the time, what customers are using is either devices and groups or policy and objects. So the policy packages are where you assign firewall policies. So in this case, I have just two. I have a branch policy package and I have a hubs policy package. So everything I'm pushing to any of the hubs is going to all of them, which is maybe good, maybe bad. But here it shows the installation targets. So I have the policies themselves, and then I have the installation targets. And you can add and remove from your device list the targets. And so in this case, I've selected the groups for my two hubs. That makes sense. And the same thing here for my branch policy package. I've accepted the groups of the branches. So if I add another branch, it would automatically get these policies. I think that's enough of the firewall objects is where you would create like address objects if you wanted to reuse. Let's say you had a branch address summary that you wanted to use in multiple policies or multiple routing configurations. You would create those objects here, and then they could be used in the other components. Here I have a VIP, which hopefully we'll get to. This is the for the ingress. So this is what we call our DNAT configuration we do also have a wholly different way of managing NAT that looks more similar to other vendors, but this is what we think is the easier way to manage DNAT configurations. So we call them VIPs. And here I have configured, this is one of the public IPs that's associated, I think, with my East external load balancer. And I have it mapped to an internal server on port 80. So hopefully we'll get a chance to look at that. And then that's configured. So that's the VIP, that's the object itself. It's configured in this hub policy package. Here I have the policy that says traffic coming into port 1, which is going to be our external interface that's associated with the external load balancer. Going to port 2, that would be our internal interface. And then I specified that object as the destination. So that kind of engages the DNAT piece of it. I also enabled SourceNAT. That's general recommendation for internet ingress. We can mitigate that if customers can't use SourceNAT for whatever reason. There are some things we can do with FGSP, similar to what we've already talked about. But if possible, we recommend customers just enable SourceNAT. Okay, let me
Martin,
go. Yeah.
would you be able to show us like an equivalent of like a show IP interface brief kind of thing here, just to get a quick pulse on what that instance looks like from an IP perspective?
Yeah, let me grab, I'll start with
One or
with
any one of them.
one of the east. So directly from the orchestrator, from FortiManager here, I can pull up an SSH session. And now I'm working directly on that FortiGate. So this would be the first FortiGate. It ends in 0. So it'd be FortiGate 1 or FortiGate 0 for the east branch. And I can do show system interface. And this shows me the actual configuration on the interface. I can also, another useful one is get system interface. And this will show me the result of the configuration, if that makes sense. So you notice that these are configured with DHCP. So that doesn't mean that these addresses are changing, but it means that we're relying on the vWAN hub network to give us the right IP address. So we don't want to interfere with that. You could change it and make it static, but it's always going to be this IP. So in this case, port 1 is 10.212.244, and port 2 is 10.212.230. Now, if we go back, let me pull up. Go back to the vWAN here. It's always helpful to me to cross-reference these.
Mm-hmm.
So we're in the East Hub and the NVA, and now we have a new one that's getting created here, but this is the one we're looking at. So I can get some basic info here. I can say get info, and these should be the same IP addresses we were just looking at. So 10.212.230, 10.212.244. And then this is the public IP that we can use for VPN termination.
VPN, yeah.
Mm-hmm. And this is the IP of the second instance.
Yeah, perfect. Thank you.
Yeah. Now, what we can also do, and this is actually when we spoke earlier, there's some new stuff here I hadn't seen yet. So if we click on Manage Configurations, this is usually collapsed, but there's a settings section here. We can get information about the instances similar to what we just saw, right? Just in a little different format. But we can also click on Internet Inbound, and it will show us the name of the Azure resource. So this public IP exists in my subscription, in my resource group. And it shows the IP address. So that's pretty handy.
That's for the Ingress.
That's for the Ingress, exactly. Yeah. And it also shows what's configured currently. I don't know. I think it just says the number. I don't know if it'll actually show us the rules, but maybe if we can get it configured, we'll see what it looks like. So that's as far, I haven't seen it before yesterday. I don't know when they pushed it to the portal. Maybe it's been a while, but I hadn't seen it before. So it's pretty cool. And this is also where I can create an additional IP address. Oh, I'm sorry. I can't create it here. That's right. That's right. I do remember this discussion. So you have to go create the IP address and then it will be available here in the dropdown. So if I had a spare, I don't think I have one anywhere, but if I had a spare one, it would show up here. So you go and you just regularly, like you would create a public IP resource. And we can do that if you want. Let's go here. I'm going to just create public IP. We're working in East, right? East US. So it does have to be standard SKU. That's really the only requirement. So that should be, I mean, the refresh. There it is. So here's my new public IP. Okay. So now we can go back to vWAN, hubs, East US hub, NVAs, manage configurations, internet inbound, add. And it's not there. It's supposed to show up now. Maybe I'm going too fast. No,
Is it in the same resource group?
it is, yeah. And I think I selected East US. Let me double check. Oh, I didn't. It never works when you do it wrong. Can I change regions? I don't think I can. Oh, sorry. There we go. Fortunately, this is fast. Okay. There we go. East US. Okay. Look at that. I did it again. There we go. East US hub. NVA. Manage. Internet inbound. Add. Hey. Okay. So while that's saving, we can come back over here and we should see some new unauthorized devices here. So this is where this is how they'll show up. And I can go like this and authorize them. And I'll just click OK. I don't need to assign anything at this point.
Nice. So it goes, could you have multiple 40 managers, Martin? In other words, if customers are migrating, let's say, from their on-prem to Azure and they spin up a VM in Azure for this, could you have it in a couple of different places? How does that work?
You can. FortiManager has a high availability feature, so you can spread, but it does need to share the database, or you'll end up in weird states, right? So yeah, so you would usually have one that's primary, and then the others. I'm not honestly super familiar with that because I haven't done it myself, but that's my understanding. I do know we have high availability, and I think one of them maintains the master database, but if I remember right, you can connect and manage from either of them. It just synchronizes back to the master database. And that's also how they do migration. So if you, like you mentioned, maybe you're moving to Azure and right now you have a physical appliance, maybe it's getting close to end of life. You could spin up a virtual appliance in Azure, configure it as part of the HA group. You can have more than two, I know that. So, and then it will synchronize the database. And then I'm not sure what you do if there's a promotion or if you just shut down the old one. I'm not sure how that piece works, but that's how they migrate the database. So now I'll have, that's going to show up in managed FortiGates, and it'll take a little bit, but FortiManager will recognize that this is a vWAN hub deployment, and it will automatically create a group for me. And then it will expose some of those Azure vWAN specific features as well. So sometimes it takes a refresh. Sometimes I have to log out and back in. I think I'm just too impatient, but eventually it shows up. So, so let's see, what should we do next?
Martin, I think just you mentioned earlier about a little bit about the upgrade, how you would put like a second set of instance in parallel. Is this a good time to talk about it, or are you going to cover it a little bit later?
No, that's a good thing to discuss now. So, if you were doing an upgrade, so right now, I think I'm on.
Yeah, I saw that it said required upgrade, for example.
Okay. So maybe 745. Yeah, I think 745 is out. So if I wanted to upgrade to 745, I could just do it and take the downtime and be fine. Like maybe it takes 5 minutes, right? It's not a huge, but for some customers, that's not an option, right? And that's one of the reasons they're in vWAN often. So, so what I can do is I can take offline essentially one at a time. And you could do this from the GUI. You could do it directly from the GUI on the FortiGate. There are ways to do it from FortiManager, but maybe because I'm a command line guy, I just think it's easier this way. So if let me just show the interfaces again. So we have this is configured. So I have some VPNs configured to the branches. I have a loopback that I've created for my BGP ID. router ID. And then I also have, these are my two primary ports. So these are the actual, if this were an appliance, these would be my physical interfaces. These are my VNICs. So port 1 is external facing. So that's the one where the public IP is associated to it, and also where the load balancer is associated. And port 2 is internal facing. So any spokes, anything express route connected, or any virtual network gateway connected, or cross region, anything I'm communicating that's a connected network would go through port 2. Port 2 has the BGP peering to the virtual WAN hub router, so it's receiving all those networks.
That's facing the internal load balancer, and the port 1 is the external load balancer.
Yes, exactly. And this is, these are the ways we can communicate directly on the interface. So these are data interfaces, which means they're passing traffic all the time, right? But if I send traffic to that interface, will it respond to it? Based on this configuration, yes, for these services. So I can ping the interface. There's actually a HTTPS running on the interface, and that's configurable. We can configure the port, or we can disable it altogether. A lot of times customers enable it or use it at first and then disable it. So that's why it's enabled on the default deployment. Same thing with SSH. FTM is for FortiManager communication. So both interfaces we can communicate with FortiManager from. Probe response. This is how we communicate with the load balancers. So we communicate with the external load balancer from port 1. We communicate with the internal load balancer from port 2. So if we wanted to take only one of the FortiGates out of service and then upgrade it and then put it back in service and take the other one out, this is what we do. Now, the way the load balancer works in Azure is it's involved in the initial flow configuration, but then it's not involved after that. So at least for TCP, UDP, it steers every packet, but for TCP, it only sets up the flow. So what that means is when we disable probe response, that doesn't necessarily mean automatically now everything's going to get rerouted. So a lot of times customers will plan this out. They'll do okay, we're going to do an upgrade. So I'm going to take one of them out of service and maybe I'll wait 5-10 minutes. Maybe this depends on, what their traffic's like. If they know they have really long-lived flows that they want to wait to expire, they could wait an hour. It's up to the customer, but first step would be to take it out of service. So config system interface, edit port 2. And then usually what I do is I just do this. There's a way to append, but I don't know if there's a way to just remove one. So usually I'll do this and I just remove probe response. Assuming I want everything else. Maybe this is a good time to evaluate, right? Oh, maybe I don't need HTTPS anymore. But assuming I want all those, so that one thing. Now there's no write config in FortiOS. It's automatically assumed that you want to do what you're doing. So as soon as I click next, it's going to apply that setting. And I can do now, let's see if I can remember the IP address tag for. One 168. I can't remember it. Do you guys remember the magic load balancer or
Oh, the Azure.
60, yes,
Yeah. Okay.
63.
Let me find.
I'm guessing now. I've typed it so many times I should remember it, but I don't.
Yeah, 63, 129.16.
Thank you. So what I see here, oh, this is a different, so this is the problem with that. This is some other traffic. So I see it came in and then I see traffic going out, but it's different. You can tell by the port. So it comes in on port 8008. That's the probe, default probe request. And then I'm not responding. So you can see on port 1, I have a request come in on 8008, and then I have a response go out also in 8008 because I haven't disabled probe response there. So right now, this instance, which is the 0, the first instance, is pulled from the Azure Load Balancer backend. So any new sessions at this point are going to go through the other FortiGate.
Yeah, so in this method of upgrade, essentially we are degraded to one instance. We've taken one off the air, right, of the load balancer.
Right.
So that's one way to do it. And if the customer cannot handle the degraded piece of it for however many seconds or minutes it takes, then the other option is the way you mentioned earlier, have a whole full parallel deployment and then cut over.
Right. Right. Yep. And that will still, now that's not going to be a perfect solution because you're still going to have to reestablish sessions. The sessions aren't going to sync between those two clusters unless you get really sophisticated. I mean, if it's, you could configure FGSP between everything, but there's really no automated process for that. You just kind of have to know, okay, this is super critical. We're going to build this up. We're going to synchronize sessions, and then we're going to cut over. The trick though is it would work in some scenarios. It wouldn't work in other scenarios. So anything that's switching routing, you can move sessions over. But if you're changing load balancers, or if you're then you can't move sessions between load balancers, right? So so even that's going to be a difficult
Right, and IP changes
proposition.
as well, right?
Yeah,
Like VPN,
you
peer
might,
IP changes and those
yeah,
things.
yeah. You'd have to
Yeah.
if you did it. So if you were doing SD-WAN only, and you brought up all the tunnels on the new infrastructure, and while the old one's still there, and you configured session synchronization, then you could just advertise this new one as new available routes, and your sessions could fail over. But it would only work for the SD-WAN piece of it, right? It wouldn't work for any east-west inspection or any internet exposed anything. It would only be for that SD-WAN stuff. So the short story is I had customers do that, but I've had customers ask about it, and then when I explain what it takes, then they decide, oh, I can deal with a little hiccup. Usually. Yeah, so that's certainly another option. When you do that, so we have that, right? We've deployed a new instance set inside the East vWAN hub. I haven't configured it here yet, but we can just assume that I have, and we can go back to, let's see. Let's go back to the hub overview routing. So here, just to for bearings. This is my resource group. This is my vWAN. I'm in the East US hub, where we deployed the second NVAs. So those are both right here. I have two different managed applications. So if I wanted to switch from one to the other, right now I have routing intents policies applied. So it's as easy as this, right? And then I can save that. Now it'll take a few seconds to save, but if everything's configured on the back end, once I save it, then I'm going to be using the new system as soon as the route gets implemented. So there will be sessions that have to be reset, but there should be no downtime when you do that. Does that make sense?
Yeah. But if it's SD-WAN, you would still need to change the IPs.
I need the new tunnels. So
Mhm.
everything has to be configured and ready. Yep.
Yep.
Yep. And you can do that ahead of time. So you could have tunnels configured to the second deployment and ready to go and have everything configured. So it's not a problem. It's just work that you have to do to prepare.
Mm.
Yep. So let's try this. So let me go to the documents here, docs. So here's our docs access, and I use this continuously. So here's public private cloud. Here's all the stuff we support. Here's Azure. And then we have two Azure vWAN guides here. So they should look familiar. Next-gen firewall or SD-WAN and next-gen firewall. So you can click here. And we do still have, if you're interested, that handy handy documentation I did for creating VXLANs and rerouting traffic. But don't use it. I mean, it works. It works fine. It's just harder than the easy way. So if we go to deploying SD-WAN on FortiManager, where is it? I'm missing it. There's an internet. Maybe it's deploying here. Here we go. Configuring internet inbound and DNAT policies. So there are two ways to do it now. And this is to go GA, we wanted to have this in the GUI. So this is the new way. In the early previews, we had it only through this way, through the CLI. And so the way this works, because the load balancer is part of the managed application, so it's running in an Azure subscription, not in the customer subscription, and the customer doesn't have direct access to it. But the FortiGate is also running in the Azure subscription. And so the FortiGate has access that's been granted to it by Microsoft. So it's AIM access to configure the load balancer. The FortiManager doesn't have any access to do that. So the way it works, if I go in here to the FortiManager, I think I have to do it this way. So I have to make it active. I've already done that. So this FortiGate is active, and that means this is the FortiGate that's going to communicate with that's going to make the API calls to configure the load balancer. So I make it active, and then I can edit rules for the load balancer. Now, when I edit these rules, once I push them, The configuration gets pushed to the FortiGate, and then the FortiGate makes the call to the Azure backend. So the FortiGate's doing all the actual work. It's the configured on the FortiManager, but then the FortiGate's doing the work. Does that make sense?
Yeah, and you get this for both internal and external load balancers.
No, we can't touch the internal load balancer. That's configured with HA ports, and there's nothing else, nothing we can change on.
No visibility into that one.
No visibility. The only visibility you have on that one is
Is
if you
that
go,
IP?
is the IP isn't even exposed. So if I go, that's a spoke, yeah. So if I go to a VM that's running inside one of my spoke networks, I can go to the interface of that VM.
Oh, the effective routes.
And the effective routes. This is the only place you'll ever see a load balancer IP, and
Is
only
the
if you have
next hop.
routing intents applied. If you don't have routing intents applied, that it won't show up. Yeah. So this is the IP address,
Mhm.
and you can tell because here's one of my routing intents policies, right? Here's another one. Here's another one, and here's another one. So those are the 4 routing intents routes, 2 policies, 4 routes that are coming, and that's the load balancer IP. Now notice these ones have so so these are cross region routes, and this is going to be, these are routes to my branches that are getting advertised, and you notice that they have still BGP routes coming, so they're still getting ECMP. And this is actually a new change that they've added to create a different deployment possibility. We're not sure if we're going to leverage it yet or document it, but rather than, so this goes back to one of Cynthia's early questions about, do you create a tunnel to every FortiGate? The reason they're leaking now these routes instead of just giving the summary routes is that theoretically then we could have 5 different instances all connected to different networks. So I could have a VPN tunnel to my data center on one, and a VPN tunnel to, maybe stores like 3 through 7 on one, and stores 1 through 1 and 2 on a different one. And then I could manually load balance based on which tunnels are going to which FortiGates. Does that make sense? And then rather than doing like everything active, I could balance what I think are going to be my most active tunnels to different FortiGates. And then the return traffic will only go to those FortiGates that are advertising it instead of going back to the load balancer. So this is a new feature that the vWAN team has recently implemented. Okay, let's go back to here. So now I need my my team's overview is getting in the way here. Can I move it to the other screen? Yes. Okay. So I'm gonna skip out on this. I don't want to change that. Okay. I'm in East. So what I need to configure this is this the right one? This is the wrong one. It's the wrong one. Okay. These get hard to tell. Oh, I named them. I should just read it. Okay. So what I need here is the name of my IP address, the Azure resource name, in order to configure my outbound rules. So I create a new rule. And this is interesting because it's a security rule and a load balancer rule. So it looks like we're creating a security rule, and we're creating an NSG rule. And at the same time, we're also creating the load balancer rule that corresponds to the NSG rule, or potentially multiple rules, which is kind of unusual and cool that they let us do this. So I'll give it a name, rule 1. Now it applies on a specific public IP. And I give it a destination port or port range. Now, this is something you can't do anywhere else. So I could do 82,000. This would probably take the day to apply, but at least theoretically I can do that. And then I can also specify a source address. They're talking about maybe removing this because the idea is that the firewall is going to do the security. So maybe also everything should be wide open when you open it here, but for now it's an option. Customers can choose who can access this. So I click OK. So now hopefully that makes sense. I've created the NSG and I'm going to, based on the same information, create the load balancer rule. There's not any details here, you'll notice. So like I'm not selecting, is this a floating IP? I'm not selecting TCP reconnect, like none of the load balancer options are there, which means it's fixed. So it's always going to be floating IP. All those details of the load balancing rule, it's always going to be 5 tuple, I think, at this point. They're all fixed. Again, that's continuous discussion with the vWAN PM team. Should we open it up? Should we allow changes? Should we allow more features? And it's just driven by what customers request. So there are also temporary rules. So sometimes customers will want to just temporarily open something up so they can test something out and then have it expire. So that's a kind of separate option. But then I'll apply that. And in theory, if I click install now, it should push that to the FortiGate, which will then push it to the load balancer and the NSG.
And there's no visibility to this load balancer from the Azure portal side.
No, the only visibility you have is that one section that we were looking at here. So this should update, but that will be it.
And by floating IP, you meant the floating IP setting on the load balancer, right?
Yes.
And that is enabled by default.
It is. Yep. Yeah, so what that means is it passes the packets through without modifying them. So when the FortiGate, in this case, when the FortiGate receives it, it will solve the public IP destination.
Yes. So FortiGate does have, is configured to accept that as well.
Yep.
Those packets that are.
I can show you that. Yeah.
Yeah.
So this is what we did. This is the and this is the piece. So if we go back to that documentation, this should look exactly like this, right? So this is what the FortiManager is doing on the FortiGate, which then the FortiGate pushes to the load balancer. So config permanent security rules, edit rule 1, source address 000, destination port 80, applies to this public IP, next end. So we could do that manually on the FortiGate and it would have the same exact result.
Yeah, I think it would be good to see the setting. I remember running into an issue with another customer where it would be good to see how it is set up on, like, what's that setting on the FortiGate to at the guest OS level or at the OS level to accept those packets kind
Yeah,
of coming in with the IP of the load balancer.
yeah,
If you have it handy and could show it to us quickly, that would be a good setting to be aware of.
yeah.
And is it always enabled or do we need to enable it?
It has to be enabled, and it would be per rule, most
Mm-hmm.
likely. You
Mm-hmm.
could, it depends, like you could, let's say everything from this public IP,
Mm-hmm.
regardless of which service I want to forward to the same backend resource, I
Mm-hmm.
could match everything all at once for that public IP and forward it to the same place, or I can match it on a per port basis.
Right.
And I could forward different ports, different places. Um, so let me show you. So first of all, this is cool, right? Now we can see that rule here. So it did succeed. It's in the Azure portal. Um, I'll show you two places. So, and actually, let's see here. It should give us to edit. So we should see the rule here too. Same thing.
Mm-hmm.
Okay. Now, to create that policy is we call it a virtual IP or a VIP. It's
Mm-hmm.
also DNAT, right? That's more industry standard terminology. So here's where I have the VIP itself configured. So I'm matching that public IP, and I have to configure a range. So I'm just matching it and itself, and then I'm mapping it to an internal. This is going to be one of my spoke VMs. I could map it anywhere theoretically. I could send it to another branch. I could send it across express route. I could even send it to another public IP because all I'm doing here is just translating the packet. And then where I send it is based on my routing and my firewall configs. But here I'm just saying which I'm going to receive a packet destined to this IP and I'm going to translate it to this IP. And then here I say I'm only going to do port 80. So I could just turn off port forwarding entirely, and it would forward everything, any packet destined to here, it would translate to here. So
Yeah,
I'll
so
show
by the
this.
virtue of the DNAT, it is taking care of accepting those packets. I think in some guest OSs, there are two different configurations required, but
There,
looks
there are
like
here, there
the,
are here too. No, this is just configuring the NAT itself.
okay.
Or PAT, I guess would probably be more accurate, port address translation. But the policy, the firewall policy also has to be enabled. So here's the matching firewall policy. So I just called it virtual IP in. It's coming in my public interface, going out port 2. Now, if I was forwarding to a branch, I may have to specify a tunnel here instead of port 2. Or if I'm forwarding to a public IP, I'd have to say I'm going to allow traffic to come in port 1 and back out port 1. But this has to match, like, where do I really want to send the traffic, right? And then my destination is that VIP. So here I can go back and see the same view here. And then I'm selecting, this is the layer 4 piece of the firewall rule, selecting HTTP as the service. And I can set a time, always allow it. And then in this case, so this is actually not DNAT. This is very confusing, especially for these VIP rules. This is SourceNet. So this configures the DNAT piece and that it matches on this rule. That's all I need for the DNAT. In this case here, what I mean when I'm selecting NAT and use outgoing interface, I'm source natting the packet as well. So I'm changing the destination to that internal server IP, and I'm changing the source to the interface of port 2. So then when the reply comes back, it'll come back symmetrically. So that's optional. We could use FGSP and rerouting for this as well. So that's the two rules. That's what they look like on FortiManager. I could show you them on FortiGate as well, but it'd be the same. It's a different UI, but it'd be the same configuration. We configure the VIP and we configure the policy. Does that make sense?
Yep. Thanks, Martin.
So I do have, that is East Spoke. I do have Apache installed there. So let's see if it works. Let me get that IP address right here. Nothing.
Demo gods. Good opportunity to troubleshoot.
Yeah, okay. So we'll go here. It should be coming in to one of these two guys. So let's just start with the top one, and I'll SSH into it. And actually, I'm going to do port 1 host. Oops.
Does it automatically push the changes that we just did?
I did push them. It doesn't automatically do it, but I did push them. That's what
I
usually
must have
put this
blinked.
install.
Yeah. Okay.
Okay. So let's see. There may be an NSG on the. Okay, don't see it here. So let's go to the second one. There we go. So we're coming in on port 1. Okay. So then we need to see, where did we send it? We sent it to this guy, which is 102204. 102204. And that should be going on port 2. Let's make sure we're doing the right thing with it. See anything? Okay. Let's check show firewall address. So this will show our address objects, which should include is it an address objects? Okay. 1204. I'm sending it the wrong place. Why doesn't it work? Why doesn't it work? Okay, so let's change that. Objects. Very detailed change request there.
Woohoo!
Yay!
Awesome demo. Thanks, Martin.
Sure.
Wow.
Yeah.
Thanks, Martin. That was a great demo, and we'll pick this up in the next session. Thank you again for joining us, and we'll see you in the next session.
Sounds good. Thank you very much.
Thank you, Neil.
Thanks.
Thank you, Martin.